Good day once again, my name is Graphics. Today we'll be talking about collision. Now, collision can be simply defined as the contact between two bodies for a short duration of time. And we have two types of collision. Number one is the elastic collision. Now, when you say the elastic collision, they say that it's a collision whereby there's a rebound between the two bodies after they have collided. That means when the two bodies are coming together and they tend to be an impact, they separate again. That means in this kind of system, the energy is what? Is conserved. The total kinetic energy of the system is what? Is conserved. Right? So what am I trying to say is that if I have two body A and what? Body B moving in the same direction. Now we know body A will have its own mass A, and body A also is moving with an initial velocity of what? A. And body B too has its own mass of B and initial velocity of what? B2. Now let's now assume that the speed of A is more than the initial speed of A is more than the initial speed of B. What happened? A will catch up with B. Now when A is moving and it collides with B, what happened? If the two body tends to separate, probably A, now there is not a backward movement of A, and what? And B keeps moving forward, right? Or definitely A slows down and the speed of B increases again due to the impact of A. Now the body has come together and is separating. This is before impact and this is what? After impact. Now the mass of A is still remaining the same, but now we have the final velocity of A. The mass of B is still remaining the same, and we have the final velocity of what? Of B. So we should know that the law of conservation of energy is that what? The momentum before impact is equal to the momentum after impact, right? So we say that my M1, my MA, UA for the first one, plus MB, UB for the second body is equals to MA, VA plus MB, VB. So this is the formula for a body that has undergone elastic collision. This is the formula for a body that will undergo what? Elastic collision. Now one thing you need to understand is this. This is before impact. And this is what? After impact. Right? So now we know MA is mass of body A, maybe in kilogram or in gram. B, mass of body B. UA, initial velocity of body A. UB, initial velocity of body B. VA, final velocity of body A. VB, final velocity of body B. So we'll move forward. Now we'll go to inelastic collision now. Inelastic collision. Now the first thing here is this. Just like I said earlier, if I have another body A and they're moving in this direction, and I have another body B that's moving in the same direction, right? This body A has a mass of A, body B have initial velocity of A, body B have a mass of B, initial velocity of what? B. Now, when they are moving, probably the speed of A is greater than, the velocity of A is greater than what? The velocity of B. And A catch up with B. As it's catching up with B, just like a truck, a heavy duty truck is hitting a sports car. Now what happened? Instead of it to hit and separate, it hits the sports car. This is A, this is B, and what? They stay moving with what? In a common velocity V. Out together. So B will now start moving with the velocity of what? Of A, because now A is now moving, has more impact and more momentum than B. So in this case we'll be having V into brackets MA plus what? MB, because now the speed of B is irrelevant, because now it is A that is now pushing it, because it has more speed and more strength than B and more mass. So what we're going to say here, we will now say that the momentum before impact MA UA plus MB UB is equals to what? V into bracket what? MA plus what? MB. So this is what we call inelastic collision. What I'm trying to say, that in an inelastic collision there is no rebounds. In an elastic collision there is a rebound. In that collision, the total momentum, the energy, the total kinetic energy is not conserved. While in elastic collision, the total kinetic energy is conserved. A good example of an elastic collision is that when you hit a ball on the ground and the ball bounces back to your hand. That is a good example of what? Elastic collision. Now, let's take this example. It says an object A of mass 20 kg moving with an object moving with a velocity of 3 meters per second. Make an head-on collision with object B of mass 10 kg moving with a velocity of 2 meters per second in the opposite direction. Full stop. If A and B stick together after collision, calculate their common velocity. Now the key word there I want you to hold on to is what? They stick together. So what you do now, it shows that it is what? It is an inelastic collision, because I told you that when the bodies stick together after collision and they tend to move in common velocity, it is said to be what? Inelastic collision. There is no rebounds, right? So recall that my M1, or since I'm talking about object A and B, to be MA UA plus MB UB is equals to V into bracket MA plus what? MB. Why I'm using A and B is because of what? We're talking about two objects, which is what? Object A and B. Now let's write out the parameters that we have to put into this word, this equation here. Now the mass of object A, MA, mass of object A, which is MA, is given as what? 20 kilogram. velocity, because this object A is moving with a velocity of 3 meters per second. So we say that the velocity of object A, that is UA, is equals to what? 3 meters per second. So I'll call it initial velocity. Initial velocity. And it makes an head-on collision with object B of mass 10 kilograms. So the mass of object B is equals to what? Which is MB. That will give me 10 kilogram. Then the initial velocity of object B, that is UB, is equals to 2 meters per second and is moving in opposite direction. So if A and B sticks together, now the keyword is B is moving in what? Opposite direction. It said it made an head-on collision with object B of mass 10 kg moving with a velocity of 2 meters per second in opposite direction. It means that object B is going against object A. They are opposite each other, right? So that means the velocity of object B is negative because it's going backward, while that of A positive is coming forward. So like I was telling you earlier, that A tends to have a bigger mass, 20 kg, and B have to have a smaller mass, 10 kg. So when they collide, what happens? A tends to push B away. Then B, this is A, and this is what? B. So it tends to go to the direction of what? Of A. Are we good? So we say we should look for a common velocity. So if we put our value into this equation here, my MA is what? 20. My UA is what? 3 meters per second. Plus my MB is what? 10. My UB is what? 2 meters per second. So because it's going opposite direction of A, and that is negative, we have minus 2 equals to our final velocity V, which our common velocity we don't know, but we know that our mass is what? 20 plus 10, because mass of A is 20 and mass of B is 10. So from here, 20 times 3 is 60, minus times plus will give you minus. 2 times 10 is what? 20, equals to what? 20 plus 10 is 40, is 30. We have 30V. So 60 minus 20 is 40, equals to what? 30V. So divide both sides by 30. V will give me 40 over 30, and that will be, to give you 40 over 30, and that will be so 40 divided by 30, 1.33 meters per second. 1.33 meters per second. So that is a common velocity for that. Thank you very much.